What AFPM does here is something, basically it controls temperature and material flow in variable layers depending on the part geometry. And if you talk about like something like a brick and mortar kind of a thing, so basically between layer, in all these 3D printed components across the XZ axis or YZ axis, you will understand, I mean, you will know that there is the strength, mechanical strength across this axis is much lower compared to other axes, and that is because of the layer adhesion issues or isotropic issues that we talk about. But with this kind of AFPM technology, with the better software control, what happens is alternate layers are printed on different flow rates and temperatures, which ensures much higher component strength compared to traditional FFF or FDM 3D printed outputs. If you talk about, compare this to a traditional, say SLS or FDM FFF or SLA output, we are talking about a material that can deliver around 50 to 55 MPa. We also have materials that can deliver up to 70, 75 MPa at very, very less cost compared to traditional FDM or FFF machines. In this regard, not only this, higher strength, higher mechanical strength. So we're talking about ASTM D638 test here. And if you need to know more about this, we'll be happy to discuss this in one-to-one call with you all. So again, the cost is much lower, and your strength here, mechanical strength, is much higher for all the axes. Again, we have received patent for this technology in India and in the US as well. Both these patents are granted, and we have been working on this, as I said, past 3 years, and